Yesterday we have learnt different types of magnets, that is natural and artificial magnets, right? Next, magnetic materials and non-magnetic materials, and let us learn about how the magnets are utilized, especially in finding directions and in toys, how to prepare your own magnet. All these things we can learn, right? Poles, the regions near to the ends of a magnet are known as poles of the magnets. So if you look at what is a pole, the region near to the end of a magnet. So there are two ends. So there are two regions that are near to these ends. So both these regions near to the ends are known as poles of that magnet. I have drawn three different shaped magnets. One is bar magnet, one is horseshoe magnet, another one is cylindrical magnet. So for all of them, there are two regions near to their ends. So those regions are known as poles of the magnet. If you take, we know that magnet can attract the magnetic materials. Magnet can attract magnetic materials. Will magnet attract the magnetic materials throughout? Will magnet attract the magnetic materials throughout its length in the same way? No. Magnet will attract the magnetic materials very strongly at the poles, whereas little less in the middle region. So, the magnetic strength is more at the poles. Magnetic strength is more at the poles because the magnet will form magnetic field lines. The magnetic field lines are very close to each other near at its poles. Hope now it is clear, the board. Right. So, what are poles? Poles of magnet are the regions near to the ends of a magnet. Magnetic strength is high at poles because magnetic field lines are close to each other at poles. See, I have drawn the magnetic field lines. Okay, these magnetic field lines, they are close to each other. They are close to each other at the poles, whereas they are little far away from each other. Little far away from each other in the middle region. Okay, so such that the magnetic strength is high at poles, whereas it is less in the middle region. Right. And magnets, they were kept on utilized by many people from olden days onwards. Right. There was an emperor in the China whose name is Huang Ti. He was having a chariot with a statue of a lady on it. And this statue of a lady, it can rotate freely in any direction. And this statue has an extended arm showing the way. See, this is the chariot of the emperor. It is having a statue of a lady which is having an extended arm. And this extended arm always was showing south direction. So whenever the emperor used to go to new places, he used to find the directions. Based on the extended arm of that statue, because that extended arm was always pointing towards south direction. So the emperor was able to locate the directions when he went to the new places. Right. So with this we can understand that the magnets mean that statue, it is having a magnet in it, and its arm is showing the direction of the south. Right. How can we use a bar magnet to find the directions? For this, what you need to do is take a bar magnet, put a mark on one of its ends so that you will not be getting confused. Marked end is showing one direction, the other one is showing other direction, like that we have to imagine. Right. Now tie a thread at the middle of this magnet and suspend this magnet from a wooden stand. How you are going to suspend it? You must suspend this magnet in such a way that this magnet must rotate freely. You have to ensure that that magnet is able to rotate freely. And when it is rotating freely in the air, after some time it will come to rest. When it comes to rest, it shows 2 points on the ground, or it will come to rest in 2 directions, keeping its both poles in 2 directions. Right? So mark the ends of the magnet showing these ends. Already you have marked one end. Right? Opposite to this end, the other pole, it is showing the other direction. So a freely rotating or suspended bar magnet always comes to rest in the same direction, which is the north and south direction. A freely rotating or freely suspended bar magnet always comes to rest in the same direction. What is the direction? North-south direction. North-south direction. The pole of the magnet that is showing, the northward. You have to first ensure that you are knowing the directions of the area where you are doing this experiment. You have already marked the directions. So, whichever the pole is showing the north direction of the ground, that will be that magnet's north pole. And whichever the pole is showing the southward direction of the ground, that is the south pole. In that way, you have to mark on the magnet. Then you go to some unknown area where you don't know the directions. Now do the same experiment with this marked bar magnet. After the bar magnet has come to its rest, then you will be coming to know which is north direction, which is the south direction of that particular area. Using this type of bar magnets, many ancient travelers, they could find the directions from centuries. So, by suspending natural magnets with a thread, ancient travelers used to find the directions when they used to go to new places. So, how can you make a magnetic compass that can show the directions? What you need to do? You need to take a thin bar magnet. Take a thin bar magnet, mark only one of its poles. Right? Now tie the middle of the magnet with a thread. That is attached to a stand, attached to a wooden stand. Ensure that magnet rotates freely. Magnet the freely rotating magnet always comes to rest in north south direction only. North south direction only. Then mark these poles and use it in finding directions. This is how you can prepare a magnetic compass. Right? So what you are doing? Take a thin bar magnet, mark only one of its poles, tie the middle of the magnet with a thread that is attached to a wooden stand. Ensure that the magnet rotates freely. The freely rotating magnet always comes to rest in north-south direction only. Then mark these poles and use it in finding directions. Okay. So how travelers used to find the directions in olden days or in ancient times? They used to suspend a natural magnet with a thread. Then they used to find the directions of their traveling places or their traveled places. So what is the north pole of the magnet? The end of the magnet that points towards the north is its north pole or north end, and the other end that points towards the south of the ground is known as south pole or south end of the magnets. All magnets, they have these two poles, whichever the shape that they may be having. Right? All the magnets will have two poles, whatever the shape, size that they may be having. If you break a magnet into two, again each piece is going to get two poles. Right? So every magnetic piece, irrespective of its size, it will have two poles. Right? So using this particular property of having two poles of magnet, travelers used to find the directions. But earlier travelers, they used natural magnets to find the directions, whereas later magnetic compass was developed. In this compass, a small box with a glass cover is present, inside which a magnetized needle is pivoted. Pivoted means it is just made, attached to a hook-like structure. How it is attached to that hook-like structure? In such a way that this magnetized needle can move freely. This compass will be having a dial with directions that are marked on it. Known directions that are marked on it. Right? If this magnetic compass is taken near to the other magnet, then it cannot show the directions correctly. This magnetic compass can show the directions correctly. You need to use it in an area where there is no other magnet. Okay. The needle of this magnetic compass indicates the north-south direction when it comes to rest. The compass, it can be rotated until the north and south marked on the dial are at the two ends of the needle. Okay, so that we will be coming to know the exact direction, that is north-south direction of that area. Why we have to rotate? Because you have marked the directions on the compass. So we have to keep rotating so that exactly the magnetized needle will be showing the north-south directions. This is how you can make a magnetic compass utilized to find the directions. And how can we make our own magnet? How can we make our own magnet? Right? If you take a bar magnet of good strength and take a pin or another iron piece and if you rub this iron piece using this bar magnet for several times, for about 30 to 40 times, for 30 to 40 times. After that, if you just check that iron piece, it will start showing the magnetism, means it attracts the small pins like substances, right? If you, after magnetizing a needle like thing, if you just suspend that needle in water, okay, on a plastic type of material, if you keep that needle, automatically that needle will be aligning itself in north-south direction, right? So otherwise you take a cork and insert that needle in that cork. Finally, that cork begins to float again without rotating. First it starts rotating. After some time, it comes to rest without rotating. And the directions that are shown by this magnetized needle will be north-south, right? Okay. So like this, we can make our own magnet. So remaining things we can discuss in tomorrow's class.